LDRs and thermistors are resistors that have varying resistance depending on the light intensity or the temperature, respectively. This is the symbol for an LDR. This graph shows the relationship between light intensity and the resistance of an LDR. We can see that as light intensity increases, resistance decreases. We know that potential difference is equal to current times resistance. As a simple equation, we know that as V equals IR. There's a proportional relationship between resistance and potential difference. So if the resistance of a component increases, potential difference across that component also increases. On the other hand, if resistance decreases, the potential difference across that component also decreases. This is the symbol for a thermistor. This graph shows the relationship between temperature and the resistance of a thermistor. We can see that as temperature increases, resistance decreases. Let's look at how light-dependent resistors can be used in a circuit. This circuit contains a battery, a light-dependent resistor, and a bulb. It also has 2 voltmeters connected in parallel with each component to measure the potential difference across each component. The question we want to answer is, how does changing light intensity affect the brightness of this bulb? Before we look at each condition, we need to remember that potential difference is shared between the components in a series circuit. That means if the battery has a potential difference of 6 volts, and the LDR has a resistance of, for example, 2 volts, then the bulb must have a potential difference of 4 volts. That's because the potential difference of the LDR and the bulb must add up to the potential difference of the battery, which is 6 volts. If the potential difference across the LDR increased, for example to 4 volts, then the potential difference across the bulb would decrease to 2 volts. Let's first think about what would happen during the daytime when light intensity is high. We know that as light intensity increases, resistance of an LDR decreases. So when light intensity is high, resistance will be low. Because potential difference is proportional to resistance, if resistance is low, potential difference will also be low. This means there will be a low potential difference across the LDR, let's say 1 volt. Because the potential difference of both components must add up to 6 volts, the bulb must have a potential difference of 5 volts. This high potential difference would cause the bulb to be brightly lit. So in high light intensity, the bulb turns on. Now let's consider what happens at night when the light intensity is low. At low light intensity, resistance of an LDR is high. A high resistance across the LDR means that the potential difference across it will be high, let's say 5 volts. That means the potential difference across the bulb would be 1 volt. This low potential difference would cause the bulb to be dimly lit. That means the bulb is dim or turns off when it's dark. This is useful for getting your mobile phone screen to go dark when you put it to your ear. The low light intensity causes the screen to go dark. Now let's look at how thermistors are used to control appliances as temperature changes. This circuit is very similar to the previous example, but in this case there's a fan instead of a bulb. This could be the cooling fan inside a computer, which needs to turn on or speed up when the components inside the computer get too hot. As the computer is used, the temperature of the components increase. The resistance of a thermistor decreases as temperature increases. So when the thermistor gets hot, there will be a low resistance. The low resistance of the thermistor means the potential difference across the thermistor will be low, let's say 1 volt. This means the potential difference across the cooling fan will be 5 volts. This high potential difference causes the fan to turn on or speed up, which cools down the computer. As the computer cools down, the temperature of the thermistor decreases. When temperature is low, the resistance of the thermistor is high. This means the potential difference across the thermistor will also be high, let's say 5 volts. The potential difference across the fan decreases to 1 volt, and the low potential difference causes the fan to slow down or even turn off. This means the computer's cooling fans turn off when the temperature is low and they're no longer needed. Here are some practice questions on light-dependent resistors and thermistors. Pause the video and give them a go. As light intensity increases, the resistance of an LDR decreases. As temperature decreases, the resistance of a thermistor increases. As resistance decreases, potential difference also decreases. When light levels are low, there's a low light intensity. This means there'll be a high resistance, so there'll be a high potential difference across the LDR. A high potential difference across the LDR means there will be a low potential difference across the bulb. This makes the bulb glow dimly.